Worksheet 13, taking a look at these, solve the triangle using law of sine. Well, whenever I have a triangle situation given just the sides, I'm going to draw the triangle. So here is a triangle, 60 degrees on angle A. So this is A, B, C. A is 2 and B is 6. So the first one that would be most convenient to find would be angle B, since I have A, and B. So I'm going to do side A over the sine of angle A is equal to side B over the sine of angle B, which when I cross multiply, solve out, I get that sine of B is equal to 6 sine of 60 over 2. Sine of 60 is just rad 3 over 2, so this is 6 rad 3 over 2, which is 3 rad 3 over 2. Uh-oh. You may notice that 3 rad 3 over 2 is bigger than 1, which means that there is no angle, which is outside the range of sine, so there's no angle B that would make this triangle work. So there is no solution for this example. For part B, I also have a triangle with an angle A, which is 45 degrees. So A, call it B, C. Side B is 2. Side A is 1.8. I'm going to set up my law of sine situation. 1.8 over the sine of its opposite angle, 45, will equal 2 over the sine of its opposite angle, B. Cross multiply and solve, I get sine of B is equal to 2 sine of 45 over 1.8. Sine of 45 is rad 2 over 2, so this is just square root of 2 over 2 times 2 is just square root of 2 over 1.8. And then B will be sine inverse of that number, rad 2 over 1.8. So I'm going to go to my handy calculator, type in sine inverse of rad 2 over 1.8. Before I do that, I'm going to check something. In this problem, I'm dealing in degrees, so I'm going to go to my mode and make sure that I am in degree mode. Enter. That way I get my answer back in degrees. So I'm going to type in sine inverse of the square root of 2 divided by 1.8, and that's 51.78 degrees. So I'm going to write that in for B. It is 51.78 degrees. It's 51.78 degrees. Well, now I can find C by taking 180, which is the whole triangle, and subtracting off the two angles I already have. So 180 minus 45 minus 51.78. 83.22, so this angle here has to be 83.22 degrees. That's my angle C. And now I can find side C, setting up another law of sine situation. I'll use my given information, so these two sides, 1.8 over the sine of 45 is equal to side C over the sine of angle C, which is 83.22 degrees. So side C will equal 1.8 sine of 83.22 over the sine of 45. Okay, so if I go to type that in, 1.8 sine of 83.22 divided by sine of 45 is 2.527, or 2.53. So now I have each of my sides. My last step is just to clean this up, write my final answers. I found the measure of angle C, which was 83.22 degrees, and the measure of angle B, which was 51.78 degrees. I found side A, which was, oh no, I did not find side A, I was given side A. We found side C, which was 2.53. Okay, next. Suppose the sides of a triangle of length 9, 12, and 18. Find the largest side of the triangle of the nearest tenth. Well, again, I'm going to sketch a triangle so that I have some point of reference. I know I have sides length 9, 12, and 18. Well, largest angle occurs across from the largest side. So my largest angle will be here. I'm going to give this some letter, or I'll call this a variable. Let's call it x, will be the measure of this angle. I'm going to use law of cosines, which tells me that c squared equals a squared plus b squared minus 2ab, to cosine of angle C. So in this case, I have my opposite side, 18 squared equals my two other sides, 12 squared plus 9 squared minus 2 times 12 times 9 times the cosine of x, the angle I'm looking for. I'm going to bring these over to the left, so I have 18 squared minus 12 squared minus 9 squared is negative 2 times 12 times 9 cosine of x. Then going to do my multiplications and arithmetic. I end up with, looks like 99 equals negative 216 times the cosine of x. So cosine of x equals negative 99 over 216. So that x is cosine inverse of negative 99 over 216. Which means that x equals, go over my calculator, second cosine negative 99 divided by 216. 117.279 or 117.28 is what I'll round it to. Degrees. Again, make sure your calculator was in degrees, or you checked it on the last example. For this one, I'm going to find the area of a triangle using the best formula. I have two. Area of my triangle is 1/2 AB sine of the angle between them. And my other formula is Heron's, which is the square root of s minus a, s minus b, s minus c, where a, b, and c represent the sides, and s is half the perimeter. Well, in my first example, I have two sides and the angle between them, so my first formula would be the best one, because I have all that given information. My area will be 1/2 24 times 17 times the sine of the angle between them, which is 150. Well, 150 is in quadrant 2 and has a reference angle of 30. Since sine is positive in quadrant 2, sine of 150 is just the same thing as the sine of 30, which is 1/2. So this area is 1/2 24 times 17 times the sine of 30, which is 1/2 of 24 times 17 times 1/2. So 1/4 of 24 is 6, so this is really just 6 times 17. Canceling these halves with the 24, leaving with 6. And 6 times 17 is 102, so my area is 102 units squared. For the second one, I have all three sides, so I can find the perimeter first, which is 11 plus 20 plus 13 is, let's see, 24, 44. 44 over 2 is 22, so that's half my perimeter. Then the area is the square root of that number times 22 minus 11, which is 11, times 22 minus 20, which is 2, times 22 minus 13, which is 9. So rather than multiply all this out, I'm going to try to find perfect squares. 22 factors to 2 times 11, so then times 11, times 2, times 3, times 3. So it looks like I have a perfect square of 2, 11, and 3. So I can pull all those perfect squares out, and with 2 times 11 times 3, which is 66.